All right, guys, let's start this thing. Number 1, what's the answer? 7 square root of 2. Once again, guys, it's kind of like combining like terms. You have 3 of something plus 4 more of that same something. It's going to be a total of 7 of that same something, right? Now that's adding, but when you're multiplying, it's just a question of rearranging. Multiply coefficients together and multiply your radicals together. So what's the answer to number 2? 6 square root of 6 is correct. Again, because 2 times 3 is 6. And the square root of 3 times the square root of 2 is also 6. So you're going to have 6 square root of 6 as a final answer. So this is your answer right here, 6 square root of 6. How about the answer to number 3? What's that? Correct answer is 20. Now, if you're wondering how we get 20, let's show our work here. Let's rewrite it twice. 2 square root of 5 times 2 square root of 5. So technically you would multiply 2 times 2 and get 4. Whoa, what's happening in my... Hold on a second. So this is what we have so far. 2 times 2 times the square root of 5 times the square root of 5. And we all know that the square root of 5 times the square root of 5 is really the square root of 25, which becomes 5 again. So when you take a radical and multiply it with itself, when you take a square root and multiply it with itself, you just end up with the value inside the square root. So we really have 4 times 5, which equals final answer 20. So on number 3, final answer is 20. Number 4, we're going to distribute. So the square root of 3 times 4, what is that? Square root of 3 times 4. That's kind of like saying x times 4. What's x times 4? 4x. But in this case, you don't have 4x, you have what? 4 what? 4 square root of 3. And then likewise, you're going to take that square root of 3 and multiply it by negative square root of 5. That's kind of like if you had a negative 1 square root of 5 with a 1 square root of 3. So you multiply positive 1 times negative 1, you get your negative 1. And the square root of 3 times the square root of 5, what do you get? Square root of 15. There you go. And the square root of 15 cannot be simplified, so that's your final answer. You don't have to put the 1 if you don't want to. You could just leave it like that. 4 square root of 3 minus square root of 15. And let's now try number 5. That would be the answer for number 4 up here, because there's nothing else to do. You can't really subtract square root of 3 and square root of 15. You can't simplify the square root of 15. So that's it. You can't combine like terms. It's over. Now, number 5 down here, you're going to have to distribute and combine like terms. So 2 times 2 is 4. 2 times square root of 3. What's 2 times square root of 3?
2 square root of 3.
Positive 2 square root of 3. And then how about square root of 3 times 2? Again, plus 2 square root of 3. And how about square root of 3 times square root of 3?
3.
That's just 3. Now, if you want to show your work, you could write it as a square root of 9, because square root of 3 times square root of 3 is square root of 9. But the square root of 9 at the end of it all is just 3. So we still need to combine like terms here, guys. The middle terms, positive 2 square root of 3 plus 2 square root of 3, what's that? 4 square root of 3. It's kind of like saying 2x plus 2x is 4x. But in this case, 4 square root of 3. And now we need to combine the square root of 9. This square root of 9 is really positive 3, right? So I really need to combine this 4 out here in the front with the 3 that's out here, right? Because the square root of 9 is really just 3. So I'm going to add 4 and 3 together. That's going to be 7. So I have 7 plus 4 square root of 3 as my answer. Now I cannot combine those because they're not like terms, so that's it as far as it could go. Any questions? Okay, guys, so let's continue with number 6. Does anybody have an answer for number 6? Minus 2. You're saying the answer is negative 2. You're right. The answer is negative 2, right? So all that work, or this whole thing, after you do all the work, you're going to get a nice, beautiful negative 2 as an answer. 2 times 2 is 4. 2 times negative square root of 6 is negative 2 square root of 6. Now when you distribute positive square root of 6 times 2, that's going to be a positive 2 square root of 6. And when you distribute positive square root of 6 times negative square root of 6, that will be negative square root of 36, which takes you back to 6, right? So when I combine the middle terms, you have a negative 2 of those guys and a positive 2 of those guys. They completely cancel out. And let's also remember that this outside 36, square root of 36 is really 6. So this is really a negative 6. Let me replace that with the negative 6 right there. And let's combine the 4 in the front with the negative 6 at the end. That'll give us negative 2 as our final answer on number 6. Do me a favor, ladies and gentlemen. Let's go to number 6 right here. And let's write down the word conjugate. Write down the word conjugate right next to number 6. Because we need to be able to understand what a conjugate is. It's when you take that binomial, the radical binomial, and you simply change the sign that's in the middle. So 2 plus square root of 6, when you multiply it by its conjugate, 2 minus the square root of 6, the radical values completely disappear. Okay, so we need to know that when you multiply a radical binomial by its conjugate, the radicals disappear. And that comes in handy on number 8. But let's first look at number 7. You have a fraction. You do not want the square root of 3 in the denominator. You don't want any radical values in the denominator. So what would I do on number 7 to get rid of that square root of 3? Multiply by the square root of 3. So up on top, I'll end up with 2 square root of 3. And on the bottom, I end up with, what is square root of 3 times square root of 3?
3.
That's just 3, right? You guys want to, let me do a little side note here. The square root of 3 times square root of 3. Let me do this. Let me change the square root of 3 to look like 3 to the 1/2 power. Because that's really the square root of 3, right? Now, don't copy this down, just hear me out. So if I did look at my denominator as 3 to the 1/2 power instead of the square root of 3, and let's say I didn't want a 1/2 power, what would I have to multiply by? I'd have to multiply it by 1/2 also, because when I multiply with the same base, what would I have to do with the exponents? Add them together. And 1/2 plus 1/2 is 1 whole. Does that make sense? So the reason why I'm explaining this with rational exponents, I mean, it's easy just to say, oh, the square root of 3 times the square root of 3 is just 3. But we need to understand that rational exponents also work, that when you multiply it with the same base, you add 1/2 plus 1/2, and you get the 3 to the 1 whole power, which is just 3. We're going to use that in future problems. Sorry about that. That was just a little side note. Anyways, that's our answer, 2 square root of 3 over 3. There is nothing to cancel. There's nothing else to do with the square root of 3. We're done. Let's move on to number 8. So down here, it's not enough to multiply both top and bottom by the square root of 6, because this is a binomial down here. And if you multiply by the square root of 6, you still end up with square roots. As a matter of fact, it gets uglier. So what we need to do is multiply by its what? Starts with the C. Conjugate. So we're going to multiply by its conjugate. What is the conjugate? It's the same exact values, except the middle sign changes. It used to be a plus, now it's going to be a minus. And of course, what you do to the bottom, you must do to the top. 2 minus the square root of 6 also up here. So do you guys want to work on the top or the bottom first? Bottom, okay. So on the bottom, if I go 2 times 2, I get 4. If I go 2 times negative square root of 6, what do I get? Negative 2 square root of 6. And if I go positive square root of 6 times 2, what do I get? Positive 2 square root of 6. And last but not least, positive square root of 6 times negative square root of 6. Negative square root of 36, right? Okay, which is ultimately just the 6, right? So I want to keep this as negative 6 instead of negative square root of 36. So anyways, the middle terms, the negative 2 square root of 6 and the positive 2 square root of 6, they cancel out. They're opposites. So what I have left on the bottom is a 4 minus 6 which is a negative 2. As a matter of fact, we already did this problem. So there's a negative 2 down here. Up on top, I'm going to have to distribute 2 times 2. I want to get 4. 2 times negative square root of 6 is negative 2 square root of 6. You with me so far? Okay, now the question is this. Is there anything else that I could do with this answer?
Yes.
Could I cancel out the negative 2's?
No.
No. Could I cancel out the 4 and the negative 2? No.
You could make simpler.
You could split the root. I mean, not split the root. Split the denominator to each term. It's kind of like this, guys. Look, watch. Let me do another side note here. If I go 4, take away 2, divided by 2. All right, let's just pretend. What's the answer here? What's 4 take away 2 divided by 2? What's the answer?
1.
The answer is 1, right? So, if I were to cancel out 4 divided by 2, I would get 2 take away 2, which is not 1. Or if I were to cancel out here, that'd be 4 take away 1, which is not 1. So it doesn't work. You can't cancel when you have addition or subtraction. You actually have to split the denominator and make it 4 divided by 2 minus 2 divided by 2 for it to be a true statement 1. Because right here, 4 divided by 2 is 2. Right here, 2 divided by 2 is 1. And 2 take away 1 does work. So if you do want to simplify, you have to split your denominator to each of the terms. Let's go back up here and let's split that denominator to each of the terms. We're going to have a 4 over negative 2. And we're also going to have, negative 2 square root of 6 over negative 2. And of course, 4 over negative 2, that's going to give you a minus 2, negative 2. And right here, the negative 2 does cancel with the negative 2. It disappears, so you have a positive square root of 6. So that would be your final answer right there, negative 2 plus the square root of 6. Okay, so on numbers 9, 10, and 11, all they ask us to do is to rewrite the radical as a rational exponent. Okay, so remember, well, the thing to know right there is that whatever your base is inside the root, and whatever power it has, whether the power is inside the root or the outside, or on the outside of the root, it's going to be changed to the same base to a rational exponent. That means a fraction as an exponent, and on the fraction you have the power over the root. Okay, so that's the change that we need to know. Again, it's always going to be power over root. Okay? So when we move on to number 9 here, we're going to rewrite that as x to the what power? 2 over 3. Right? And that's it. Y to the what power? Now remember, there's an invisible 2 right here because a square root is really talking about 2. And power over root, what power does the y have? A 1. So what's your power here? Power over root, 1/2. Y to the 1/2 power. We already knew that the square root is really equal to the 1/2 power. Let's move on to number 11. What's that one going to be? A to the what?
1 over 7.
Power over root. The power is 5 over the root 7. Now it doesn't matter if the power is on the inside or on the outside of the root. It's the same difference. Okay? So on number 12, what we're going to do is split that square root. So I really have the 3 times the square root of 50 times the square root of x to the 7th. Okay? So the square root of 50, I'm going to rewrite it as the perfect square number 25 times 2 and split the root. I'm going to bring down the 3 that's in the front, and I'm really going to have 3 times 5 times the square root of 2, which is 15 times the square root of 2. Now the x to the 7th, I'm going to handle it in a similar way. I know that the square root is really the power of 1/2, so it would be really nice if I could have an even power instead of an odd power. So I'm going to rewrite x to the 7th as x to the 6th times x. That way when I split the root, I'll have x to the 3rd square root of x. Now I could still multiply the 15 square root of 2 times the other. So there's the answer. Sorry.